Okay, so I'm doing letter B, and I have to find f of g of x and g of f of x, and then state the domain of each. So first I'm going to do f of g of x. G of x is just what it says here, x over x minus 1. And for f of g of x, I'll plug in the x over x minus 1, and that is 2 over x minus 1. After that, you have to make it into a multiplication. So you have the 2, and then you multiply it by x over x1, but you flip it. And you factor in the 2, so it becomes 2x minus 2 over x. See how I factored the 2 into there and into the negative 1. And then that is the answer. And now I have to state the domain. So the domain over here, x can't be 0 because you can't have a denominator of 0. And then you have to also check your domain in your original g of x. So for this, it's a denominator, so it can't be 0 either. So x minus 1 cannot be 0, so which means x cannot be 1. So our domain is this, x cannot be 0 or 1, and here's the answer. Now I'm just going to do g composed of f of composed of x. I'll do it down here because I don't have any space. And f of x stays the same, 2 over x. So it's g composed of 2 over x. And g composed of 2 over x is 2 over x in place of the x on top here. And then 2 over x minus 1 in place of the x over here. So I have to make the 2 over x and the negative 1 have common denominators. So the common denominator would be x over x for that. And then I can, just like the last one, flip it to make it a multiplication. Oh, first actually, before you flip it, combine the two fractions in the denominator. So it becomes 2 minus x over x, and then you can flip and multiply. The x's cancel, and it becomes 2 over 2 minus x. And then for the domain, over here, because it's in the denominator, it has to be greater, it has to be anything except for 0. So cannot be 0, so negative x cannot be negative 2, which means x cannot be 2, so domain here cannot be 2, and the domain back in our f of x, the denominator can't be 0, so we put 0 down here. Okay, that's it.